Good morning, students. I am going to start the explanation of the CBSE sample paper 2020-21. Okay, and if you have any query, you write in the chat box. Is it clear, students? Is it appearing clearly? Yes or no? Clear now everything? Okay. First question I am going to start. Actually, before going to discuss about this question paper solutions, right? And how many questions will be there? There are. Is it clear, students? My voice? Aditi, is it clear? Right. Okay, students. I'm going to start the class. You listen very carefully. Right. And there are five sections. In the A section, what is there? First section A. In the A section, what is there? There are 14 one-mark questions are there. Right. Then you will get the 14 marks. In the B section, okay, there is a in the B section we have two 4 marks questions. You will get as 16, 8 marks. In the C section, you have 9 2 marks questions. You will get 18 marks. In the D section, you have 5 3 marks questions. You will get 15 marks. In the E section, you will get 3 5 marks questions. Okay, you will get 15 marks. The total you will get is 70 marks. This is the paper analysis. 1 mark questions 14 you will get. 2 case study questions. This is the new pattern. Case study questions are there. 2 in that 4 sub questions we have to attempt, right? 2 for the 8 marks. Let us discuss about the paper now. We will start. And you listen very carefully. If you have any query, you write in the chat box. Okay, let us go for the first question. Right? What is the name the physical quantity which has unit joule per Tesla? Is it clear, students? My voice and everything? Okay, good morning, students. Right, good morning to all. Listen it here. Clear now, students? Okay, Aditi, thank you. Going to start. Okay, name the physical quantity which having the joule per Tesla unit. We know the joule is the unit of the work, right? Work by what is there? Work by Tesla is the unit for the magnetic induction. Magnetic induction. That means it is the W by B. What is the W by B? W by B means joule per Tesla. Joule per Tesla is the unit for what? We know torque formula. Torque is equal to mg sin theta, right? Then from this sin theta not have any unit. Okay, sine functions not have any unit. Then from this m is equal to we write as tau by B. Okay, then tau is the torque. Torque unit is what? Force into distance. Newton meter. Newton meter is nothing but joule. Okay, torque is nothing but a force into perpendicular distance. It is nothing but work only, right? Newton meter. Force into displacement is the work. This we write is joule. Magnetic induction is Tesla. Okay, then we write as it is the magnetic moment. The answer for this is magnetic moment. Okay, answer for this is magnetic moment. This is the answer. Is it clear, students? If you have query, you write in the chat box. Let us go for the next question. Mention one part of electromagnetic spectrum to which a wavelength of 21 centimeter belongs to. Right? This you have to study the uses of all electromagnetic waves. I gave some code to remember the electromagnetic waves in the increasing wavelength, right? Gx uv imr, right? Gx uv imr, it is the code that in that wavelength will be increases when you will go to right side. Right now, you know this one. G means gamma rays, x rays, u means ultraviolet rays, p means visible, I means infrared, m means micro, and r means radio waves. Wavelength will be increases. You have to remember the wavelength range of all waves. Along with that, you have to remember the uses of them, wavelength range and uses of each wave you have to remember. And what they gave in the question, mention the part of electromagnetic spectrum in which the wavelength is 27 centimeters. The wavelength is the 21 centimeter. It belongs to which radiation and its use they are asking, right? Then you know that from 30 centimeters to 1 millimeter, okay, 30 centimeters to 1 millimeter range, this is belongs to microwaves wavelength range. This one, microwaves wavelength range. That means 30 centimeters to 1 millimeter is the microwave. Microwave means what you will write. What is the use of the microwaves? Radars we will use. Okay, radar we will use. And where you will use? In the microwave ovens we will use, right? This is the correct answer. Okay, they are asking that 21 centimeter wavelength radiation use. 21 centimeter wavelength will come in this range, right? Okay, this is 30 centimeters to 10 to the power of 1 millimeter. How means how many centimeters? 1 millimeter means 0.1 centimeter, right? 0.1 centimeter to 30 centimeter that the radiation belongs to microwaves. Microwaves uses radar and microwave ovens. Okay, Twinkle. Right, let us go for the next one and give the ratio of velocities of speed of light 4000 and 8000 angstroms. Ratio of speed of light they are asking. Speed of light in vacuum. Speed of light in vacuum is 3 into 10 to the power of 8 meter per second. It is constant, right, in the vacuum. When it enters into the other medium, it will be changes. They are asking the ratio of speed of lights. Ratio of speed of lights. Okay. Ratio of speed of light is constant. Speed of light is same in the vacuum. That's why the ratio become 1 by 1. That means answer is 1 is to 1. Clear, students? Right. Let us go for the next question. That is electron. Electron with charge E. Electron with charge E. This is the electron whose charge is minus E. It is traveling, whose mass is M. It is traveling along a circle, right, with certain velocity V. Okay, in the magnetic field of induction B. Okay, the perpendicular magnetic field they are telling that the charge is moving in the perpendicular field. That means what they gave in this, the velocity is perpendicular to field they give. Charge is moving with some velocity, right? That velocity is perpendicular to field. When velocity is perpendicular to field, charge force on the charge is qvb sin theta. Theta is 90 degree. Then you will get the force as qvb. It is the maximum, but this force serves as centripetal force. Due to that, the charge will move in the circular path, right? Charge moves in the circular path. Now the charge follows a circular path of radius capital R. The charge follows a circular path of radius capital R. In time small t, electron travel halfway round the circle. What is the work done they are asking, right? Work done formula is F bar dot S bar. Is it right? Then we write F bar dot S bar as S bar we write as velocity into time. We know that velocity is equal to displacement by time. From this, displacement is equal to, we write as velocity into time. We write here force into velocity into time, we write. This we write as W is equal to Fv cos theta into T, we write. But here theta is angle between the F and V. Angle between F and V. But that theta is 90 degree. That's why how much work we are getting? You can answer work is 0 because cos 90 is 0. Cos 90 0 means work will be 0. Clear third question? Right, let us go for the fourth question. What they are asking that is, this is a solenoid they give. Solenoid inductance they give. What is the formula for the inductance of solenoid? Fourth question. The fourth question, inductance of solenoid formula is nu naught n square al or nu naught capital N square A by L. This is the formula. What is a solenoid? Solenoid is a coil, right? This is a coil, right? And this coil has capital N number of turns. Number of turns. Okay, capital N is the number of turns. And A is the area of cross section. Area of cross section. A is the area of cross section. And L is the length. L is the length. Self-inductance formula is this one. L is the length of solenoid. And then question, that self-inductance, if the current through the solenoid is reduced to half, then what happens to the self-inductance? But the self-inductance is independent of current from this formula. It depends upon nu naught, number of turns per unit length, area, length, length of solenoid, but it is independent of the current. Capital L is self-inductance is independent of current. Independent of current. Independent of current means what we can write? L is independent of current means L does not changes. Right? What change would you expect in inductance? No change. Inductance will be remains constant because it is independent of current, right? Okay, let us go for the next question. That is in the fourth B. This you compare with the general equation I is equal to I naught sin omega t, right? You compare with this. Okay, what they are asking, that alternating current will be there. Alternating current means current varies with the time. Then what is the effective value of current? Effective value of current means RMS current we have to find out. Actually, alternating current always varies. Alternating current means the current whose magnitude changes with the time and direction also changes. Then they are asking that what is the reading shown by the ammeter? Effective value of current, how much current passes through the wire means what you will give, IRMS current you will give. They are asking the frequency also. Frequency is new frequency of the wave. Then we can compare these two equations. When you compare these two equations, right? I naught what you will get 10 and omega what you will get 314. Then we know from this omega formula, you know 2 pi nu. Okay, 2 pi nu is equal to 314. They are asking the nu to find out. The nu is equal to what you will get from here. The nu is equal to, we will get is 314 by 2 pi. You simplify it, pi value 3.14. And finally you will get the new value as 50 hertz. Clear students? Fourth question is completed. I am explaining speedily because uh, I'm not going to waste your much time. Okay, right. If you have any query, write in the chat box, and if you have answer, then that also you write in fast like me. Okay, good. Let us go for the next question. And now next question is fifth question. The fifth question is that what is the value of angular momentum of electron in the second orbit? According to Bohr's second postulate, angular momentum is integral multiple of h by L equal to nh by 2 pi. L is the angular momentum. You know that formula, mvr is equal to nh by 2 pi. You know this formula, na? mvr is equal to nh by 2 pi. Then n is the orbit number. This L is the angular momentum. This is the formula for the angular momentum. Angular momentum, right? Writing clearly appearing, na? Any data missing? Angular momentum is LH by 2 pi. Here orbit number is second orbit. Second orbit angular momentum they are asking. Second orbit means n equal to 2 we have to write. 2h by 2 pi we have to write. 2 to cancel. We will get the h by pi. We will get the h by pi. Here na next one is the photoelectric experiment. Potential energy required to stop the electron. Potential required to stop the electron means that is the stopping potential. Stopping potential is the 4 volt. They are asking the maximum kinetic energy. What is the formula for the maximum kinetic energy? E V naught. That is E into V naught value is 4 volt. Then answer is the 4 electron volt. Very simple, right? Next one. In the decay of neutron. Actually, this is not in syllabus. Okay. Free neutron decay. That means neutron if it is converted and proton and electron, then what elementary particle will emit along with the proton and electron? Okay, देखिए one neutron if it is converted into proton means 1p1 or we take 1p1 it is also equal to 1h1. Okay, you see here this is the neutron converted into proton and electron. Along with this one element will emit. What is the name of that element they are asking? न्यूट्रॉन प्रोटॉन इलेक्ट्रॉन तरीका कन्वर्ट करने के समय में और एक एलिमेंट एमिट होता है. न्यूट्रॉन प्रोटॉन तरीका कन्वर्ट करने के समय में इलेक्ट्रॉन के साथ और एक एलिमेंट एमिट होता है. उसका नाम क्या है ये पूछ रहा है. उसका नाम क्या होता है? उसका नाम एंटी न्यूट्रिनो होता है. राइट. आंसर इज एंटी न्यूट्रिनो. आंसर इज एंटी न्यूट्रिनो. क्वेश्चन क्या है? जब न्यूट्रॉन ओके न्यूट्रॉन प्रोटॉन इलेक्ट्रॉन तरीका कन्वर्ट होने के समय में ओके ये प्रोटॉन इलेक्ट्रॉन के साथ और एक पार्टिकल एमिट करता है. उसका नाम क्या है? दैट इज एंटी न्यूट्रिनो. एंटी न्यूट्रिनो. राइट. लेट अस गो फॉर द नेक्स्ट क्वेश्चन. इफ प्रोटॉन ये वाला क्वेश्चन है और नोट में और एक क्वेश्चन बताता है. प्रोटॉन न्यूट्रॉन का तरीका कन्वर्ट करने के समय में प्रोटॉन न्यूट्रॉन तरीका कन्वर्ट करते तो प्रोटॉन न्यूट्रॉन तरीका कन्वर्ट करते तो उसके साथ एक पॉजिट्रॉन के साथ न्यूट्रिनो एमिट होता है. ओके. देखिए वेरी केयरफुली सुनिए सुन लीजिए. न्यूट्रॉन प्रोटॉन तरीका कन्वर्ट करते तो इलेक्ट्रॉन एंटी न्यूट्रिनो एमिट होता है and proton neutron तरीका कन्वर्ट करते तो positron neutrino emit होता है. right. Right. In our question in the seventh question they are asking that when neutron converts into proton and electron along with that one more element will emit. What is the name of that? It is anti neutrino. And in this reaction, next question, in the following nuclear reaction identify the unknown labeled value of x. This x value we have to identify. Okay. Identify unknown labeled x. X is what? Okay, for that we have to see here. This is the 10. Okay, this is the neutrino actually. This is the neutrino. This is 10. Here 11 become 10. 11 become 10. That means it may be like this. 11 sodium 22 plus minus 1 A0. If it is react with the electron, then you will get the neon. Plus along with that neutrino. Is it balanced? You see this neutrino is not have any mass number, not have any atomic number. Then answer is what? Answer is electron. Answer is electron. Okay, it is react with the electron means 11 minus 1 10, 22 plus 0 22. It is balanced. Answer is electron. Okay, clear students? Now what happens to the width of depletion layer if the doping concentration is increased? If doping increases, what happens? Doping increases means depletion layer what happens? Depletion layer decreases. What happened? Students, is it clear? Everything is appearing? Okay, good, Twinkle. doping increases means depletion layer, what happens? Depletion layer, what happens? This is our question, right? If doping increases, depletion layer decreases. Depletion layer decreases. Depletion layer means what? Depletion layer means what? Depletion layer is a doping increases means this is the PN junction diode. PN junction diode. This side positive ions are in the P region, negative ions are there. Okay. In N region, positive ions are there. If it is doping is more means more holes are there. Holes concentration increases in P region. Electrons concentration increases in N region. Due to the increase in holes and electrons, this region will be decreases. This region will be decreased because in this region also electrons hole centers. This region is called as depletion region, right? It is free from electrons and holes. Then that region will be decreases. Answer is decreases. Half-wave rectifier. Half-wave rectifier. What is the output frequency? Output frequency equal to input frequency in half-wave rectifier. That means answer is 25 hertz. This is in the half-wave rectifier. If the same question, if they will ask for the full-wave rectifier, if they will ask for the full-wave rectifier, what the full-wave rectifier will do? That is output frequency is equal to 2 times of input frequency. Output frequency is equal to 2 times of input frequency in full wave rectifier. If the same question instead of half rectifier, if they will be the full wave rectifier, answer is 50 hertz. Okay, right. Now next question. Let us go for the voltage drop across the PN junction diode is increased from 0.7 to 0.71. What is the increase in voltage? Increase in voltage is 0.71 minus 0.70. Voltage increased from 0.7 to 0.71. The increase in voltage is 0.01 and increase in current. The change in current they give us 10 milliamperes. Increase in current is 10 milliampere. Milli means 10 into 10 to the power of minus 3 ampere. That is 10 to the power of minus 2 ampere. Then question is the dynamic resistance we have to find out. Resistance is the change in voltage by change in current we have to write. Okay, dynamic resistance formula change in voltage by change in current. Change in voltage is what? 0.01 and change in current is what? 10 to the power of minus 2. Then what is the answer? What is the answer? 0.01 by 0.01. You are getting the answer 1 ohm. Right. What is this? Which specially fabricated PN junction diode used to detect the light? Right. There are 3 diodes are there. Optoelectronic diodes. They are respond for the light. Then to detect the light, which diode is used? You know that first one, the photodiode, right? Photodiode is used to detect the light. Next, let us go for the next question. And these assertion region questions. Assertion region questions means first question is we have to select the answer in these 4 options. Okay, in these 4 options you have to select any one option. Okay, what is this assertion region? One statement you will give. Okay, one statement you will they will give one statement. Okay, right? V is equal to IR. They will give one statement, assertion. Then in the reason they will give like this. According to Ohm's law, V proportional to I. Right? V is equal to IR is the statement. Okay. And according to Ohm's law, V proportional to assertion they give V equal to IR. Reason they give V proportional to I. Assertion correct है. Reason भी correct है. रीजन असर्शन का करेक्ट एक्सप्लेनेशन है. V इक्वल IR के लिए उसका डेरिवेशन है ये वाला. मतलब ये क्या क्या ऑप्शन हो सकता है? V इक्वल IR असर्शन में दिया हुआ, रीजन में V प्रोपोर्शनल टू I दिया हुआ, दोनों करेक्ट है. रीजन ये उसका ये फार्मूला डेरिवेशन के लिए ये रीजन है, मतलब रीजन इज द करेक्ट एक्सप्लेनेशन फॉर असर्शन. दैट मींस द आंसर फॉर दिस इज राइट. Both A and R are true. Both A and R are true. R is the correct explanation of A. That means A option is the correct. Like this, we have to select assertion and reason. We have to tell Whether we have to check whether both statements are correct or wrong, right? One statement is right, other statement is wrong means you have to select the third option. And one statement, one both statements are correct, but the second statement is not correct explanation of first statement. For example, they will give like this assertion. They will give, okay, Sita is wife of Sita is wife of Rama. Okay, right? And in the reason they gave that Hanuma is one character in Ramayan. Hanuma is one character in Ramayan. Right? Now, for this, which option is correct? Can you tell answer? Can you tell answer? Sita is wife of Rama and Hanuma is one character in Ramayan. What is the answer for this according to assertion reason in these four options? Can anyone write in the chat box? Sita is wife of Rama. It is correct. A is correct. Hanuma is one character in Ramayan. That is also correct. Sita is wife of Rama. Hanuma is one character. Hanuma is not one reason to make Sita wife of Rama, right? It is R is not correct explanation of Sita. A assertion, right? We will select like this. Both A and R are true, but R is not correct explanation of A, right? Okay. Next, let us go for the questions now. Right. First, they gave that 12th question. You see, electric field is always normal to the equipotential surface along the direction of decreasing order of potential, right? And the negative gradient of potential is electric field. Electric field is the negative gradient minus dv by dr. Electric field is in the direction of decreasing. Dv means change in potential. E, from this, E is E direction. E is in the direction, minus means decreasing. E is in the direction of decrease in decrease in potential. That means in this the assertion is correct. Okay, true, and reason is true, and reason is the correct explanation of assertion. From the reason only we will get this one, right? That means option is what? First option, right? That means A is correct. First option is what? Both A and R are true. R is correct explanation of A. Answer is A option. Okay, answer is A option. Okay, next, 13th one. 13th one is better. Convex mirror cannot form the real image. No, it is false. It is false. Convex lens forms the convex lens forms the real images also. Convex mirror converges the parallel rays that are incidenting. Okay, converges. If the convex parallel rays are incidenting, means they will be converged like this to meet at a point. It is converges. It is true, right? A is false, B is true. Then which is the correct option? A is, you see, A is false, B is true. A true or false? This option is not there, na? Once again, we will see the question. Convex mirror cannot forms the convex mirror cannot forms the real image. Convex mirror cannot form real images. Real images it will form. Convex mirror converges the parallel rays that are incidenting. True. A is false, R is true. Is it their option? Students, can you answer? Okay, you remember it. In the option is not there, I think. Okay, let us go for the next question. Convex lens of focal length 30 centimeters cannot be used as a simple microscope in normal adjusting. Normal adjusting means image forms at infinite. Image at infinite, normal adjusting. In this moment, the magnification formula is d by f. Okay, magnification formula is d by f for the simple microscope. Okay, actually, simple microscope. What is the use of the simple microscope? It can magnifies. Magnifies means it increases the size of the. It increases the size of the object. It increases the size of the object. But what happening it here? Convex lens is used to increase the size of object. If the focal length is 30 centimeters, this cannot be used as simple microscope in normal adjusting. Why? Why we cannot use? We will check whether we will use or not. Okay. Then further purpose, you this one take magnification value. D is the 25 centimeters, F is the 30 centimeters. Then you will get the magnification that is less than 1. Magnification less than 1 means diminished image forms. Actually, microscope should be increased, but that means this is true statement. True statement. Why we cannot use the 30 centimeter focal length? If you find out the magnification with the 30 centimeter focal length, you are getting less than 1. Less than 1 means diminished image forms. Diminished image forms means we don't require the simple microscope as diminished. Simple microscope should make the magnified image. That's why we should not use this one, because simple microscope should be magnified. But according to this, if you take 30 centimeter, it is getting diminished image. But that's why we should not use this. Here also giving the statement that we should not use the 30 centimeter. That means it is true. And for normal adjusting, angular magnification formula is this one. It is also true. That means it is the correct explanation of the A. From this only I explained this one. That's why uh, this 14th question answer is A. Answer is A. A option. The next, let us go for the next case study questions. You have to study this Faraday's cage. What is this Faraday's cage? Faraday's cage or the Faraday's shield. Faraday's shield is an enclosure made of a conducting material. The fields within conductor cancel out. I will explain myself. Okay, you read later. Okay, this is a metal sphere cylinder. Okay, it is a metal sheet. Okay, metal sheet is rounded in the figure, and inside some hollow will be there. Okay, we know that inside the sphere, inside the charged conducting sphere, inside the charged conducting sphere, electric field is zero. Electric field is zero. Inside electric field is zero. Electric field is zero means if any material it is placed, okay, that will be safe. If any charge is given, an extra charge will be resides on surface only. Charge never enter into the inside the sphere. That's why what happens, if you will keep any elements, sensitive elements inside the sphere, that are be protected. This is said to be electrostatic shielding. Electrostatic shielding we discussed in the previous class, right? In the electrostatic shielding. Based on the electrostatic shielding, they are asking the questions. Okay, you read later. Which material we have to use to make the Faraday's cage? Faraday's cage means for the sake of electrostatic shielding. Electrostatic shielding means a metal sphere, a metal is enclosed like this in either cylinder form or the this should be a metal. Then if you keep anything inside this, that will be protected from the charge. Okay, that means we have to use the metal. Which of the following material is used to make the Faraday's cage? Faraday's cage protects the sensitive elements. Then which material we have to use? Answer, students. Students are responding. Okay, very nice. Priya Mato and Aditi, right? And let us continue. Okay, which material we have to use in this? Copper we have to use, because copper is the metal. And a real world Faraday's cage is the car. Okay, if you sit in the car, okay, car is made with the metal, and if any lightning will be occurs, lightning means mass heavy charge. The charge will resides only on the surface. The persons will be protected from the uh, charge which are coming from the clouds. Okay, clouds, right? And during the lightning, the car is the safety because it acts as a Faraday's cage. Faraday's cage means it acts like a electrostatic shielding. Electrostatic shielding. Right, let us go for the next question. The next question is that what electric force? What is the electric force inside the Faraday's cage? It is zero, no force because electric field is zero. If isolated point charge placed in the Faraday's cage, okay, Faraday's cage. In the Faraday's cage, we are placing the isolated charge. If you place this is the Faraday's cage. In this, if you place some charge at here, then what happens to the charge on the surface? Okay, actually, like this, it will be there. If you take the sphere, you can understand. If you keep plus q at here, if you place the plus q in the inner surface, minus q will be induces on the inner side. On the outer side, plus q will be induces. What this plus q will do? This plus q which is placed at here, it will attracts all the minus in the metal sheet. That's why minus forms inside the surface. On the outer surface, all the minus will becomes to inner means positive will be there on the outer. Then on the outer surface, positive charge will be forms. That means plus q. On the inner surface, minus will forms. Okay, right. Then what is the answer at here? Answer it is what? Right, plus q on outer surface, right? Next question, fifth question. What they are asking it here? A point charge 2 coulomb is placed at the center of Faraday's cage in the shape of cube. The number of electric field lines passing through the cube is what? This is a cube. It is a cube. At the center of the cube, we are placing one charge. The charge is they give 2 coulomb it here. Okay, charge is the 2 coulomb. Okay, then they are asking at the shape of the cube of side the cube side they give as 9 centimeter. How many field lines passes they are asking? Field lines is nothing but flux. Electric flux formula according to Gauss law, q by epsilon naught. Then q is 2, epsilon naught value is 8.85 into 10 to the power of minus 12. You simplify this, 2 by 8.85 into 10 to the power of 12 you will get, and in this you will get as 20 into we write as 20 by 8.85 into 10 to the power of 11 we write 20 by 8 means 8 1 the something you have to simplify and you will get some answer. Okay, actually there is some key mistake there in this. Options are wrong in this, wrong options. Okay, some typing mistake is there in this. Okay, right. Let us go for the next one. Next one is the also case study. You have to study this diagram. Okay, what happening in this one letter is incidenting it here like this like this like this, and here it is incidenting here the this is the normal drum. Okay, this is the normal drum, and this will become the angle of incidence. Light undergoes the reflection. This is the angle of incidence. Incident light ray, normal drum. That is called as angle of incidence. This is the critical angle. In this case, angle of incidence is the angle when the incident light ray. This is incident light ray, and this is the normal drum. This is the angle of incidence, and the angle of incidence is I. Critical angle is this. That means from the figure, angle of incidence is greater than critical angle. means total internal reflection takes place. Due to that, light will reflected, right? And it will be reflected. Due to this will appear as brilliance. Brilliance means brightness of the diamond is due to the total internal reflection, right? Hmm. Let us go for the due to total internal reflection. What happens? Total internal reflection conditions, first one, light should try to travel from conditions for total internal reflection. Angle of incidence should be greater than critical angle. Light should try to move from denser to rarer medium. And if angle of incidence is greater than critical angle, then total internal reflection occurs. You see here, I is this one, C is this one. C is small, C is this only. Right? I greater than C means total internal reflection occurs. Light come back into the same medium. And light is trying to move from prism to outside. That means where denser to rarer it is trying to move. That's why it is undergoes total internal reflection. Let us go for the questions based on this. Okay, see the first question. What they are asking: light cannot easily escape. Actually, you study this paragraph based on the paragraph and diagram. We in downward some questions are there. Because of time, I am not reading the paragraph. Yourself later you can read directly. I am reading the questions. Light cannot easily escape a diamond without multiple internal reflections. This is because light cannot easily escape a diamond. Light cannot easily escape a diamond. Light is not escape means total internal reflection occurs. This is the, for example, a diamond. Light undergoes the total internal reflection everywhere. Okay, like this, like this, like this, like this. Total internal reflection occurs. Means light is not going outside. Na? Light is not going outside to the diamond. Then what is the reason they are asking? The critical angle with first option, critical angle with reference to air is large. Critical angle is with reference to air is small. Diamond is transparent. Rays always enters at an angle greater than critical angle. Okay, this is our question. Actually, this is also correct. I greater than C means total internal reflection occurs. Critical angle is less. That's why total internal reflection occurs. Okay, and correct option you have to take that is in the 15th question. Na? You have to take this one. This is the more accurate answer. Okay, critical angle is less. Critical angle is less. Next, let us go for the second question. The second question is the critical angle of diamond is 24.4. They are asking that refractive index of the diamond. Refractive index of diamond formula 1 by sin C. Okay, 1 by sin 24.4, that you will get is 2.42. Already diamond refractive index you know. Yes. Next, let us go for the next question. The basic reason of extraordinary sparkle of suitably cut diamond. What is the reason for the sparkle, brilliance? It has low refractive index. It has high transparency. It has a high refractive index. It is very hard. It is has high refractive index. You see 2.42. The answer is C option. Next, uh, fourth question is: a diamond is immersed in a liquid with refractive index greater than water. Okay, liquid refractive index is greater than water refractive index. Diamond dip in the liquid. What happens to critical angle? We know that refractive index of diamond with respect to liquid formula 1 by sin C. Then from this, refractive index of diamond by refractive index of liquid is equal to 1 by sin C we write. And from this, refractive index of liquid is directly refractive index of liquid by refractive index of diamond we write is sin C by 1. Then from this we write refractive index of liquid is from this we write refractive index of liquid is directly proportional to sin C. That means if critical angle is increases, refractive index of liquid increases, critical angle also increases. What they are asking in the question: a diamond is immersed in a liquid with refractive index greater than water. Diamond is immersed in a liquid whose refractive index is greater than water. Then the critical angle for total internal reflection will be, what happens to critical angle when it is dipped in the liquid? Right? Critical angle is directly proportional to refractive index of liquid. When we have to write, you see here sin C formula, what you got? Sin C formula you got is from this nu L by nu D, right? Firstly it is in the air, okay. When it is dip in the liquid, its refractive index is increases, nu L value is increases, that's where critical angle also increases. Answer is increases. When refractive index increases, refractive index of medium increases, then critical angle also increases, because critical angle directly proportional to refractive index of medium. Liquid is the medium, na? If medium, firstly it is in the air, when it is dip in the liquid, refractive index of the medium is increases. Air refractive index is 1, and now liquid refractive index is more than 1. It is the more than 1. That's why when refractive index is increases, when you dip the diamond from air to liquid, that's why critical angle also increases. Right? Completed. Next, in the following diagram shows the diamond cut in two different shapes. What they are asking. The brilliance of the diamond is, in which brilliance is more? If total internal reflection is occurred means more brilliance. More brilliance. Here no total internal reflection, less brilliance. Less brilliance because less, no total internal reflection. No total internal reflection. Right, students? Is it clear? Very good, very good. So many members are responding. Right. And the students, can I continue? Actually, we completed till now how many questions? Oh, we have to complete this first. The brilliance of the diamond in the second diamond में brilliance less है comparing with first. Why? Because no total internal reflection. Right? हो गया. The next question. 17th one. 17th one. You see this. Right? If the first one is the, this is the current carrying wire, this is the current carrying wire. This current carrying wire dot indicated. Dot and current means wire is this is outward current, right? Dot means outward. Cross means inward current. Inward current. Okay, how the magnetic field will be generated? You have to use the right hand rule. You have to use the right hand rule. Okay. In the right hand rule, what you have to do? Around this current will be magnetic field will be formed. The current carrying wire is indicated with the dot. Around this magnetic field will be formed. Around this also magnetic field will be formed. You have to use the right hand rule. Thumb shows the, here thumb shows the outward. What about the curved fingers? When thumb shows outward, what the curved fingers indicates? Something like this it will indicates. You have to hold like this. Right hand. The thumb shows one direction, curved finger shows the circle. This curved fingers indicates the magnetic field. According to the right hand rule, according to the Maxwell right hand rule, can you tell magnetic field around the current carrying wire uh, in which the current is outward, whether it is clockwise or anti-clockwise? You have to use the right hand rule. It is the clockwise. Field is clockwise. Here it is anti-clockwise. That means here the field, if you want to draw a tangent, it will be there. Field. There is a field due to this conductor. B1 due to first conductor. Field due to second conductor is opposite. B2. Like this it will be. Okay, it was very simple. What they are asking, I will explain. In which region the field will become, at which magnetic field is to 0 due to this current carrying wires. There are two current carrying wires are there. At which region, at which region field should be 0, net field should be 0. This wire will generate the field, this wire will be generate the field. Okay, but this wire will generate the field in anti-clockwise. Means here the field is due to first one, this is the first one, field due to that one is considered as b1. B1 is up, outward, and b1 is here on the left side, downward. This is the first one. Due to the first wire, field is always at every point upward will be there on the right side. Okay, this is a wire. Okay, it carries the current outward. Field on the right side is upward. Field on the right side is upward. Field on the left side is downward. Field on the left side is downward. You see this figure. Circle is there, na? Right side upward tangent, left side downward tangent because arrow mark downward, and field b1 is upward. Due to b1 is here downward, on the left side it will be downward. Understood? You see on the left side of this first conductor, on the left side of this first conductor, okay, field downward, on the right side field is upward. And due to the second conductor, due to second conductor, left side upward, left side upward. Due to second conductor, due to second conductor, left side upward, b2, b2, okay, b2 upward, and here also b2 upward, here also b. On the left side, this is left side, this is left, left side upward na for the b2. Why? You see this cross, left side upward for the cross one, cross is the current, means left side field will be upward, right side field will be downward. Okay, for this conductor, left side is this one, right side this one. Left side what happens? Left side upward, 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 and right side of this, right here also left side upward, here also for this left side of this total left side, for this right side is this one, right side downward will be there, right side downward. You see for the second conductor, that means in which region we are getting the opposite field? In this region, in between the, in the region, this is region 1 they gave, this is region 2 they gave, this is the region 3. In region 1 and 3 fields are opposite, then the answer is region 1 and 3 fields b1 and b2 are opposite, are cancelled with each other, right now. The net field will be 0. At what situation net field is 0? In region 1 and 3, not in region 2, because in region 2 field due to first conductor, field due to second conductor in the same direction. Okay, how we know the directions? How we know the direction? Just simple, right? If in case of dot, in case of dot, right side field upward, left side field downward. Okay, left side downward, left side downward. You see left downward for this first one, for this first conductor, left side downward, left side downward b1 b1. For this right side upward, b1 b1 upward. For the cross, right side downward, for the cross right side downward b2. For the cross left side upward b2. Right? Understood, students? Good. Can I continue or stop? Your wish, because I think it will take more 1-2 hours to complete the total, because it is a 3 hours papers to write the exam, 3 hours paper to write the exam. Okay, then for the explaining more than 3 hours requires, but I will complete. I don't know at what time it will complete. I am explaining very speedily, even though it is not completing. Let us go for the next question. If you have any query, if you want, okay, Twinkle Lagori, continue it is. By right hand thumb rule. Very good right hand thumb rule. Priya Madhav. Tell me, can I continue? Right. Let us go for the next one. Draw the intensity distribution fringes with the phase angle. Diffraction at single slit. Very important for the 5 marks also. Okay, we will go for the graph. And for that, you listen very carefully. This is the phase angle. Phase angle is taken on x-axis and intensity is taken on y-axis. You will get the graph like this. Intensity will be decreases with the phase angle. Okay, on this is the y-axis. Y-axis intensity, and x-axis phase angle. This is the other graph showing the intensity distribution of the fringes with the phase angle due to diffraction at single slit. Completed this diagram. The next question. This total topic is very important. Okay, I'm not going to explaining total topic. What should be the width of each slit to obtain n maximas in double slit pattern? Okay, we are using the two slit set here. In this question, we are using the two slits. Two slits means what happens in the two slits? Hence, double slit experiment will occurs, and along with that, diffraction also occurs. Diffraction due to single slit and interference due to double slit. And in the what they gave me here, this is the diffraction pattern. The diffraction pattern. In the diffraction pattern, that is due to single slit. But here double slit they give, double slit they give, double slit. Double slit means interference also occurs due to interference when bands forms. Here like this. Single. This is for single slit. Double slit are there means this is for double slit. डबल स्लिट मीन्स डायफ्रैक्शन के साथ इंटरफेरेंस भी होगा इंटरफेरेंस की वजह से ये वाला आ रहा है छोटा छोटा वाला ये बड़ा बड़ा वाला ब्लू वाला ड्यू टू डायफ्रैक्शन ये छोटा वाला ड्यू टू इंटरफेरेंस ओके डबल स्लिट मीन्स इंटरफेरेंस डायफ्रैक्शन दोनों आता है क्वेश्चन में क्या दिया हुआ क्वेश्चन में क्या दिया हुआ विड्थ ऑफ सेंट्रल मैक्सिमा दिस इज द विड्थ ऑफ सेंट्रल मैक्सिमा विड्थ ऑफ सेंट्रल मैक्सिमा and width of interference band. Width of interference band is called as the fringe width. Fringe width formula, do you know? How many fringes forms, how many interference fringes forms in the central maxima, that are they are asking. Okay, for this you listen very carefully. The width of central maxima, for example, in this n fringes forms. One fringe width is beta in interference like this. This is the one fringe. Like this, n fringes are formed. N fringes forms means in the central maxima. This is the central maxima. This is central maxima. This is said to be central maxima. In central maxima, again bands are forming. Then the width of central maximum is n times of fringe width. Then width formula we have 2 lambda d by a. Fringe width formula we know lambda d by small d. Okay, lambda d will be cancelled. And 2 by a is equal to n by d. The number of fringes is equal to 2d by a. This is the formula for number of fringes. What is a in this? A is the slit width. What is d in this? D is the distance between the two slits. Distance between two slits. Okay, what they are asking question? What should be the width of each slit? What should be the width of each slit? Each slit width means a. Small a they are asking. From this you find the small a. From this what you will get the small a? 2d by n you will get completed. N maximas are formed in that. Okay, next question. Next, let us go for the next question. They are asking the potential energy. We will stop now. I think just I will explain the question paper, what type of questions they are asking, and for this related to this, some few important questions I will explain, and I will not explain all the questions. Okay. This is the, they are asking, deduce the expression for potential energy of a system of two charges located at a distance r1 and r2 in the external electric field. You see here, this is the charge. This is for example origin, and two point charges q1 and q2 are located at the position vectors r1 and r2. Then question is that they are placed in the external electric field. Potential energy is what they are asking. Potential energy is nothing but work done. For example, potential at this point we can take as V of R1. Potential at this point in the electric field we can consider as V of R2. To bring the Q1 charge, work done is W1. To bring the Q2 charge, work done is W2. Okay, in the electric field. And then we write W1 is what? To bring the work done to bring the Q1 charge. That we write is potential into charge, V of R1 into Q1. Because work formula potential into charge. We want to bring the Q2 charge, V of R2 into Q2. Plus we want to bring the q2 charge to q1 also, because due to q1 also electric field will be there, due to other also electric field will be there. External electric field is E, and due to q1 also electric field will be produces. That work done is the 1 by 4 pi epsilon naught into q1 q2 by r. This is the work done between q1 and q2. If a clear explanation requires half an hour time, I am not going to do the explanation. Okay, right, let us go for the next question. Relation between the E and electric field and potential, E equal to minus dV by dr. Its derivation we have to do. This derivation I will give in the link. Okay, right. Next, draw. I will give the link for you. Draw the equipotential surface in the electric field pointing z-axis with magnitude of magnitude increasing at constant rate along the negative z-axis. Okay, I will explain this one. This is the positive z-axis. This is the negative z-axis. Now what happening at here? What we have to indicate it here? Draw the equipotential surface. These are the equipotential surfaces, but the distance should be decreased when they will go left side. Just you have to decrease the distance, because electric field is increasing along the negative z direction. Electric field formula from this electric field is inversely proportional to distance. dr is the distance. When distance decreases, electric field increases. Well, you have to write in the negative z axis with the decreasing distance. Here distance is more, here distance is less. Close, they should become closer. Next, explain with the help of circuit diagram the action forward biased junction diode which emits spontaneous radiation. State the least band gap. Which diode emits the light radiation? LED. LED diagram is in forward bias. It should be in the forward bias. That's all. It will emit the light. It will emit the light. And the least band gap, energy band gap, how much it should be there? It should is 3 electron volt to 1.8 electron volt to emit the light. And minimum is 1.8 electron volt. Just last class we discussed. Next question they are asking. Just you use the flux formula VA cos theta to find out this, and induced EMF formula d phi by dt. But here theta should be not 60 degree. Okay, what they are asking it here, once we will go for the solution, because it is a problem. Chalo, let us start. Students, are you there? I don't know, Priya, till now not have any information. Okay. All the students are leaving, only 5 members are remaining. I think you are not interested. Okay, we will not go for the solutions. Only we will uh, see the question paper. Okay. Right. Later I will explain in any time. Uh, this is from this question is from the EMI chapter. Okay, AC chapter. This one EMI chapter. Okay, this is from wave optics. Okay, I think solutions I gave for you, and draw the energy band diagram when intrinsic semi doped with impurity and antimony. Antimony is what? Antimony. Antimony is the pentavalent. Na? Pentavalent impurity added to the pure semiconductor means what you will get? Whether N type or P type. They are asking what is the name of the extrinsic semiconductor? N type or P type? Pentavalent added means N type you will get. Answer is N type. Answer is N type. N type. Metal charge carriers in N type is electrons. That's all simple. Next, define the term magnetic inclination. Magnetic inclination means, for example, net at a particular point, net earth magnetic field is this one. It is making some angle with the horizontal. That is called as angle of inclination. Delta is the magnet of inclination. Inclination or dip is also. It is also called dip. Elements of earth magnetism. Very important topic. Elements of earth magnetism. I will give the link. Okay. This net earth magnetic field making some angle with the horizontal, that is called as angle of inclination. Next, horizontal component means earth magnetic field divided into two components. One is horizontal and the other is vertical. That is called as in that one component is the horizontal. Okay, right. Establish the relation between them with the help of diagram. This is the diagram relation they are asking. Okay, this is also BB you will get. BB means this is also BB. This is BH. Tan delta is equal to what we write? BV by BH we write. And BH is equal to we write as B cos delta because horizontal component. BV is equal to we will get as B sin delta. If you will squaring and adding 1 square plus 2 square if you will do, you will get the BH square plus BV square as B square cos square delta plus B square sin square delta. Then answer is B square you will get. BH square plus BV square equal to B square. Okay, these are the two formulas. Next, what they are asking, or one more question they are asking. Horizontal component of earth magnetic field at a place is root 3 times of vertical component. Okay, I will give the solution of this one. Horizontal component is root 3 times of vertical component. Horizontal is B cos delta, root 3. Vertical is B sin delta. Okay, root 3 times of B cancel. Then from this one, tan delta is equal to 1 by root 3. Then what is the value of delta? 30 degree, na? Next question. What are the characteristics of image formed by the convex lens when the object is placed between the focus and optical center? Draw the diagram. Characteristics of image formed by the convex lens. Okay, this is the convex lens. Object is placed between the focus and optical center. Here we are placing the object. Where the image will be formed? Image is virtual. Is it right? Image is virtual and enlarged. Image nature is virtual, This is object, this is image. Image is virtual, erected, upright image, and enlarged image. These are the characteristics. And draw the graph showing the variation of distance with the object. Okay, you remember the graph. Object distance this side, image distance this side. The graph will be like this there. Okay. Next question. 26th. Total 33 questions only there. A rectangular loop with initially inside the region of uniform magnetic field, independent of the magnetic field. It is pulled out with constant velocity as shown in the figure. Oh, this one. They are asking sketch the variation of the magnetic flux and induced current. Okay. First case, when magnetic flux, what happens? Variation of magnetic flux. First, the flux will be constant because flux formula is what? BA cos theta. Theta is what at here? Theta is the field is inside, area vector also inside, theta 0. We will get the flux as BA. Flux BA is constant when it is inside. When it is inside the field, when it will comes outside, field link with the area is decreasing, but inside area is constant, total area is constant, but when it comes outside loop, then area inside the loop is decreases. Area decrease means flux decreases. That means first flux constant, then flux decreases. Like this we write flux versus time. First constant, next decreases. First why constant? While going through the, when it come to here, okay, when it come to here, from here to here, area is constant, field is constant, flux constant. When it is going outside, flux decreases. That's why you will get like this. Totally goes outside means, totally goes outside like this means no area inside the field. Field is 0, B 0. Field link with this loop. That's why flux becomes 0. The next question, induced current and induced power. Current also, what happens? Firstly current 0. Firstly current 0 because flux constant. Flux constant means first current 0. When it goes outside, area decreases. Area in the field decreases. Area in the field decreases means flux decreases. That will increase the current. Means first what happens? Current 0. Then current starts from somewhere. Okay. Current starts from somewhere and you will get the graph like this. Then next, power also same you will get. Okay, because the power is equal to voltage into current. How current will varies, like that power will be varies. Current or power graph you will same you will get. Next, instead of this, if you will use the circular loop, what happens? Circular loop means graph you will get like this. Do you expect the same value of induced current? No, because it will be changes. Circular loop is changes, circular loop is different and that one is different. Catch the variation of the flux. Okay, same thing will be there, but the flux decreases, but it is not decreased uniformly. You will get like this, non-uniformly decreases because it has a uniform cross section, but circle not have uniform cross section. Its cross section is changes. Next, 27th question. A variable resistor is connected to the SL of EMF E across a internal resistance smaller. Draw the circuit diagram. Okay, I will explain what they are asking. A variable resistor. Variable resistor. Variable resistor. This is the variable resistor. Variable resistor is connected across a cell. This is a cell whose EMF is E. Internal resistance is smaller. Now this is the circuit diagram. Draw the circuit diagram completed. Plot the graph shows the potential drop across the resistance as a function of R. Okay, current in this formula is what? Current formula, effective EMF by effective resistance, capital R plus small r. Potential formula V is equal to IR, we write. V is equal to IR. V is equal to I is E by capital R plus small r into capital R. We will get as E by this capital R taken to denominator 1 plus small r by capital R you will get. Okay. You take this smaller is first capital is 0, then what you will get the v small r by 0 is infinite. Some denominator you will get infinite, then voltage you will get 0. And if r is equal to infinite, if r you write capital R is infinite, something by infinite 0, e by 1 plus 0, you will get e. That means potential increase when r increases from 0 to infinite, potential increases from 0 to e. What you will get the graph for the b. B is taken on y axis, capital R is taken on x axis. When the capital R is 0, b is 0. Capital R 0, v is 0. The origin. Now capital R is increasing, v is also increasing. And at infinite you will get the v as e. You will get the graph like this. When r increases from 0 to infinite, v increases from 0 to e. Right? Good students, you are there and you are listening. Very nice. Next, it is going to complete. And total 33 questions only there. A storage cell of battery 8 volts. A storage cell of battery 8 volts. Internal resistance 0.5 ohm. Charged with DC supply 120 volts. Using a resistor 15.5. Draw the circuit diagram. Let us start the circuit diagram. What they are asking. Yes, a question. First circuit diagram I will draw. The circuit diagram is that first a storage cell. This is a storage. Oh, here it is not sufficient place. We take the storage cell. Storage cell is this one, 120 volts. It is connected to its resistance is 15.5 ohm. It is connected to external cell. External cell is 8 volts. Its internal resistance is external cell EMF is 8 volts. Its internal resistance is 0.5 ohm. This is the circuit diagram. What we have to do? This is a storage cell, charging cell. Sorry, this is a storage cell. This is the storage cell. Storage cell 8 volts. Internal resistance 0.5 being charged by DC supply. This is charged by DC supply. Okay. 120 volts. Throw a resistance 15.5 ohm. This is a circuit diagram. Let us go for the solution. What they are asking. You see here, the current starts from here and current also starts from here. Positives are connected. Negatives are connected. Very important. Current starts from here, but it is 8 volt only. But it is 120 volts. Its domination is more. That's why the current direction is this one. Current entering into the first cell, not leaving from the cell. Current entering into the cell means through this current entering into 8 volt cell. That means 8 volt cell is charging. 8 volt cell is charging. 8 volt cell is charging. Why it is charging? Generally from the positive terminal current leaves, but not leaving, entering into the storage cell. Current is entering from high voltage cell to low voltage cell. Means low voltage cell is charging it here. Then what the question is that potential difference across the battery is what? Okay, current in the circuit we have to find out first. Effective EMF is what in the circuit? Effective EMF. Two cells are there. Okay, E1 and E2. They are in opposite direction. This is E1, that is considered this is E2. They are positive connected to positive. They are in the series wrong connection. Series wrong connection E1 minus E2 we have to do. In the series generally प्लस होता है, but wrong connection में minus करना होता है. Right? This is single current direction is not changing. That's why single path. Current is constant. E1 minus E2. 120 minus 8. What you will get? 120 minus 8. 120 minus 8. Effective EMF we will get as 112 volt. And current we can find out current is the effective EMF by effective resistance capital R plus small r. Effective EMF is 112. The effective resistance is this capital R plus small r 15.5 plus 5 16. 112 by 16. 112 by 16 you will get as 7 amperes current is passing. Then question, what is the terminal voltage across the storage cell? Terminal voltage formula E plus IR. E plus IR. Okay, E plus IR. Why E minus IR when you will use? This is during charging. During charging V equal to E plus IR. During discharge V equal to E minus IR. Okay, note, during discharge, if any cell discharges, then the terminal voltage formula E minus IR. E minus IR. E minus IR formula when you have to use during the discharge. But during charging, this storage cell is charging. That's why E plus IR. E is what? 8. I is what? 7. R is what? 0.5. Right? Simplify it, you will get answer. That answer you will get is 11.5 volts. Next question. What is the purpose of having the series resistance in the circuit? Here, why we are using this series resistance? To decrease the current. If directly we will connect to the storage cell, large current passes. To decrease current entering into storage cell, right? Okay, completed. Next, de Broglie hypothesis is what? De Broglie hypothesis is nature loves symmetry. Nature loves symmetry. Nature loves symmetry. Next, de Broglie show that the de Broglie wavelength of photon equal to the electromagnetic radiation. This solution is already there. Nature loves symmetry. Radiation has dual nature. रेडिएशन हैज ड्यूअल नेचर ना ऑलरेडी आपको पता है रेडिएशन हैज ड्यूअल नेचर मींस व्हाट पार्टिकल एंड वेव नेचर हेंस मैटर आल्सो हैव द ड्यूअल नेचर रेडिएशन को ड्यूअल नेचर होता तो मैटर का भी ड्यूअल नेचर होगा ये बताया डी ब्रोगली ओके एंड क्वेश्चन पूछ रहा है ए शो दैट द डी ब्रोगली वेवलेंथ क्या दिया हुआ लैम्डा इक्वल टू h by m ना de Broglie wavelength equal to the photon equal to the wavelength of photon equal to the electromagnetic radiation. Electromagnetic radiation wavelength we have to find out. This is the de Broglie wavelength. Electromagnetic radiation wavelength you will get E equal to mc square formula you know according to Einstein and equal to h nu also you know. Then from this mc square is equal to h nu we write as c by lambda. Then c square will cancel and mc is the momentum equal to h by lambda. Then from this one lambda equal to h by p. This is through the electromagnetic radiation and this is directly de Broglie. Both are equal. Completed answer. Next question. Deuteron. Deuteron means what? 1h2 is the deuteron. Deuteron charge is what? 1e. Deuteron mass is what? Deuteron mass is 2 units. Next one is the alpha particle. Alpha particle is the 2 helium 4. Its charge is plus 2e and its mass is 4 units. 4 units. Question क्या पूछ रहा है? De Broglie wavelength ratio. De Broglie wavelength formula h by p. But in terms of potential under root, they are accelerated with the same potential. They are asking potential constant in this question. 2m qv we have to use. Potential constant means lambda inversely proportional to root mq you will get. And lambda 1 by lambda 2 equal to root m2 q2 by m1 q1 you will get. You simplify the values, you will get the answer some 2 by 1 or something. Next question. What is the state the main impact of observations from the photoelectric experiment? Laws of photoelectric effect you have right. Laws of photoelectric effect. Do you know laws of photoelectric effect? Laws of photoelectric effect are the first one. Photocurrent depends upon intensity, right? Directly proportional to intensity of light. And the second law is that stopping potential depends upon the frequency. Depends upon frequency of incident light. V naught formula we know na, h by e. What happened? It is not working. V naught is equal to H by E into nu minus nu naught. Okay, right. Next one. Stopping potential. V naught means stopping potential. Stopping potential. And the next one is the photocurrent is in this directly proportional to intensity applied. Stopping potential is directly proportional to frequency. This photoelectric effect is instantaneous process. Instantaneous means when light falls at that moment, immediately electron emits. Instantaneous process. And the next one is the if the frequency of incident radiation is threshold less than threshold frequency, no electron emitted from metal surface. These are the laws of photoelectric effect. These are not explained by wave theory. Not explained by wave theory. Next question they are asking. Okay, read the question. Can these implications explained by the wave theory? No. Next. 29th. It is lengthy. You see the solution directly. Next, give the difference between give the 1 point difference between the nuclear fission and fusion. Fission is the splitting of heavier nuclei into lighter nuclei. Fusion means combining of solution I gave in the box. Okay, solution I gave in the notes. Okay, I will upload. Fission difference they are asking. I gave many differences. Okay, and then next question is that ferrous split into two this nuclei. Is this fission energetically possible? In the fission reaction, energy should be released. In the fission reaction, energy should be released. Is it releasing or not? We have to check. What happening? Which reaction is occurring at here? 26 ferrous, 56 split into 2 aluminiums. 13 aluminium, 28. Ferrous split into 2 aluminiums. Then is this possible? Is this possible? That is our question. We have to check. We have to find out the mass defect in this. For that, mass of reactants minus mass of products you can do. Mass of reactants is the mass of ferrous, this one, 55.93494 minus mass of product, this one. Two products are there, that's why 2 into product of this one is aluminum is the product, 27.98191. You will get something. Then you will get the energy released as in AMUs. You will get how much value you will get it here. Some minus value you will get. Okay, 0.028888 something you will get. Then energy released you will get is delta M into 931.5 mega electron volts. This delta M is negative means then energy also negative you will get. Then that value you will get is minus 26.8 mega electron volts. Minus means energy absorbed. Actually in the fission reaction energy should be released. That's why not occurs. Not occurs. Because negative energy means absorbed. But in the fission emission should be occur. That's why it is not occur. Okay. Right. Next, Gauss law. Gauss law and proof. You know this one. Gauss law and its proof. They are asking. Just simple. In the after the proof, you say that Gauss law is independent of shape. That's all. Gauss law and its proof. You have to write. Next question is what? They are asking to find out the field. Okay, if it is a thin sheet, due to this, here the electric field formula, you know, sigma by 2 epsilon naught. They are asking give the magnitude and direction of the electric field at a point on the left side of the sheet. Left side of the sheet. Here the electric field we require. This is first sheet we can take. This is the second sheet. This is the third sheet. Left side due to first sheet electric field E1, due to positive away will be there. Due to negative towards will be there. And due to positive, this is also positive. Away will be there. Right? That means net electric field. E1 formula is what? E1 formula is sigma by epsilon naught is the formula. If charge density is sigma but here charge density is 2 sigma. That's why 2 sigma by 2 epsilon naught. Next E2 formula, due to minus 2 sigma. Okay, 2 sigma by 2 epsilon naught. Only magnitude you should write. And E3 formula, sigma by 2 epsilon naught. This is sigma charge density. Instead of sigma, here 2 sigma is there in the first case. Instead of sigma, minus 2 sigma is there, but 2 sigma we have to take. And E3 we have to take as sigma by epsilon naught. Here we have to find out the net electric field. Okay, in A region, net electric field. What do we have to do? E1 minus E2 plus E3 we have to write. Why we have to write plus it here? E1 E2 are opposite, that's where minus. Don't take minus it here. Here we are taking the minus. Opposite, that's right. Then 2 sigma by 2 epsilon naught minus 2 sigma by 2 epsilon naught plus sigma by epsilon naught. Answer is sigma by epsilon naught. Means we got positive. Positive means net electric field is left side. Net electric field is left side because E1 E3 is greater than E2. Okay. Next at the D we have to find out. At the D, due to first sheet, due to positive, away will be there. E1. Due to this negative, towards will be there. And due to this plus, right side will be there. Then answer net electric field. The first chapter you will get this one. Okay, you see here, 32 question, derive expression for the current flowing through the ideal capacitor. Current formula we have to find out passing through the ideal capacitor. This is the capacitor. And we are connecting to the AC source. AC source voltage we write V equal to V naught sin omega t. We are connecting to the capacitor. Then current formula we have to derive. For that, what we have to do it here, potential across AC source equal to potential across capacitance. Potential across AC source is V naught sin omega t. Potential across capacitance is Q by C. Q equals C V naught sin omega t equal to dq by dt. We have to differentiate this C V naught d by dt of sin omega t. We will get as I equal to C V naught omega cos omega t. This we write as I is equal to I naught cos omega t, and this we write as I equal to I naught sin omega t plus 90. That's all. Next, what they are asking, if you add the resistance in the series, this is the resistance we are connecting to the series into the capacitor. They are asking to, for this phasor diagram also they are asking. Okay, I think you know very well these all things. Next one is the current flowing through the circuit. Current formula we will get as peak value of current V naught by root of x c square plus r square you will get. Tan phi formula you will get as phase angle x c by r. You remember these formulas for the second question. AC generator, you know, and label diagram working of obtain the expression for the principle of AC generator is what? Electromagnetic induction. Next question, explain how it will works with the label diagram. Oh, this is the north and south, and this is a coil, and now the coil will be rotates to the turbine. When the coil is rotates, the magnetic field will be changes. The change in magnetic field induces the EMF in this. Let us derive the expression for the EMF. For the purpose, you know, EMF equal to minus d phi by dt formula. Minus d by dt of phi formula is what? NBA BA cos theta. Theta we write as omega t. We write like this d by dt. Then NBA is a constant we write outside. Minus d by dt of cos omega t we write. Cos omega t formula minus NBA into cos omega t differentiation is minus sin omega t, omega sin omega t. Okay, then we will get as NBA omega sin omega t. Then E is equal to we will get as E naught sin omega t. Completed. This is the derivation. Next, is it possible to generate EMF without rotating coil? Rotating the coil? Yes, possible. Yes, possible by rotating magnets or by changing field. By changing magnetic field. By changing magnetic field. If you will change the magnetic field, flux will changes. Changing flux induces the EMF. Is it? According to Faraday's law, induced EMF equal negative rate of change of magnetic flux. Next, define wavefront. What is a wavefront? Locus of all points which are in the same phase. Locus of all points in the phase. That is called as a wavefront. Draw the diagram, shape of the diagram which plane wavefront passes through the prism. Okay, diagram I will draw. This is the prism. Plane wavefront is incidenting like this. Letters are incidenting, plane wavefront will be like this there. Then it will be emerges like this. Next, this is the first question diagram. Second question diagram, convex lens. This is the convex lens. Plane wavefront is incidenting. Plane means parallel letters. Wavefront will be like this there. And then they will be converge at a point. And the converging means wavefront will be like this there. Okay. Right. This is the plane wavefront and this is the converging wavefronts. This is convex lens diagram. Okay, they are asking the diagram only. And next state the nature of the refracted wavefront. Here it is the plane wavefront. Here refracted wavefront is the spherical wavefront. Okay, completed. Next, verify the Snell's law by using Huygens principle. How you will verify the Snell's law by using Huygens principle? Very simple. Snell's law, Huygens principle. You see very carefully. This is rarer medium and this is the denser medium. Two light rays are incidenting it here like this. Okay. Two light rays are incidenting. This is the normal drawn. This is the normal drawn. And light ray will be refracts and goes like this. Light ray will be refracts and goes like this. Here angle of incidence is I. Plane wavefront is incidenting like this. It is coming like this. It is incident like this at A, B. Here, this is A dash, and this is the refracted wavefront. This is B dash. In the rarer medium, the speed of light we can consider as V1. This distance is V1t, and this distance in the second medium light ray traveling. This is the speed in the second medium V2 we can take. Here the distance is speed into time, and from the mathematics, this is angle of incidence, this is angle of refraction, here also angle of refraction, this is also angle of incidence. Then Snell's law is what? For that, what we have to do, sin A by sin R we can find out from the figure. Sin A by sin R, what you will get? Sin A equal to opposite side, V1t by hypotenuse is A dash. Sin R we count, right? V2t, sin R is the in this triangle, opposite side V2t, hypotenuse A dash. Then we will get as V1t by V2t. T cancel. V1 by V2. This is nothing but 1 Newton. Snell's law proved. Completed? Okay. Next. A question. Next question. What is the consideration for the astronomical telescope? Magnification of astronomical telescope. Magnifying power of astronomical telescope is f naught by fe. Okay, considerations are two considerations will be there. Focal length of objective should be greater than eyepiece. Aperture of objective should be greater than eyepiece. Next, draw the ray diagram of reflecting telescope. Reflecting telescope diagram you know already? Yes or no? Like this it will be there. Some concave mirror we have to use. Here convex mirror light rays will be incident like this, and they will be reflected here, and they will meet in the eyepiece. Something like this it will be there. Set the advantages. Advantages: no chromatic aberration, no chromatic, no spherical aberration. Aberration means defect in the formation of image. Right? Brightness is more. Brightness of image is more. Large magnification, large resolving power. So many are there. Okay. Actually, I explained very fast because of time. Okay. Very good, Priya. Thank you to all. I closed the paper. Right. Sorry for speed explanation. Once again, I will explain later slowly one by one. I will also give the clear solutions. Because of time, I explained it very fast and in shortcut method. You see this. This is the long answer question, 5 marks question. I explained it in the very shortcut. Okay. Yes, everything I explained it in the very shortcut way. Right. This one, long answer questions also I covered. Right. You take care. Uh, if you have any query, you write now. I will tell. If you have personally, if you want any question clear, once again explanation is required, you tell me. I will explain. Okay. And this is the explanation of the sample paper and very important sample paper. Anything you want? Anything you want personally? Do you want to ask anything? Otherwise, we will close. Can I close? Ask something. For clear explanation, for every topic, I will give the link below in the description. You go for description box and open certain topic. Okay. And I will give the question number and link. Open that link and the further clear explanation will be there. One topic, one hour, half an hour, 20 minutes, 10 minutes topic will be there. And in that, I will explain. You can watch clearly because it is a full paper, 3 hours. For explanation, clear explanation, it requires more than 5 hours, 3 4 hours. Right? Okay. Thank you to all, and I am closing.